fluid mechanics. The basic concept of fluid mechanics is a science that deals with the behavior of the fluid at rest or in motion. The interaction of fluid with solid or other fluids at the boundary. So the fluid mechanics deals with the fluid rest as well as in motion condition. The study of fluid at rest, it is called fluid statistics. The study of fluid in motion, where the without considering the pressure forces, it is called fluid kinematics. That is, only we are discuss about that velocity and acceleration, these details. And the study of fluid in motion, if the pressure forces also considered, that is called fluid dynamics. In fluid dynamics, we will go to analyze in the fluid dynamics based on the Newton's second law of motion. What is fluid? A substance exists in three primary phases: solid, liquid, and gas. The substance in liquid or gas is referred to fluid. A substance which deforms continuously due to external shear forces. That is distinguished between the solid and fluid. A solid, in the attractive force between the molecules are larger, therefore more closely packed. But in fluid, the attractive force between the molecules are smaller, therefore more loosely packed. Whenever solid subjected to shear force, it is undergoes deformation, and deformation is permanent due to that shear force under this condition. But in fluid, whenever in the solid is the fluid is subjected to shear stress, no fixed deformation continuous. The deformation takes place until shear stress is applied. Next, we will go to discuss about that. In the fluid, when a constant shear force is applied, a solid eventually stops the deforming at some fixed strain angle. Wherever fluid never stops deforming, approaches to the sudden rate of strain. That is, in the diagram shows that deformed rubber eraser placed between the two under the two plates under the influence of shear forces. In the liquid, molecules can move relatively to each other, but the volume remains relatively constant because of the strong coercive force between the molecules. As a result, the liquid takes place the shape of this container as it is. It forms the free surface of the large due to the gravitational forces. Next, in the ghost, on the other hand, the gas expands until it encounters the walls of the container and fills the entire available space. This is because of the gas molecules are widely spread out. The coercive force between them is very small. Gas cannot be from the free surface. The distinct difference between the liquid and gas. The liquid difficult to compress, often regarded as incompressible. Liquid is incompressible, but gases are compressible because easily to compress, changes its volume is larger, cannot normally be neglected or related to temperature. In liquid, occupy the fixed volume will take the shape of the container, but it is no fixed volume. It changes volume to expand, fill the containing vessels. Then it is completely filled the vessel, no free space is there. If the container in liquid is filled with this container. Next, the application areas of the fluid mechanics. The mechanics of fluids is extremely important in many areas of engineering and science. Examples: the biomechanics, fluid flow through the outs and veins, airflow in the lungs, flow septal nodes, and next for in the pipeline mechanism for cold water, natural gas and switching system, and piping system network and network of heating and air conditioning. that is in piping system. Next one, meteorology and ozone engineering, the movement air currents and water currents. Next application in mechanical field is in design of pumps, turbines, air conditioning equipments and pollution control equipments. Nowadays, analysis of aircraft, sports and submarines and wind turbine, biomedical cooling of biomedical cooling system and cooling of components and etc. These are the application of fluid mechanics. Application of fluid mechanics. Next one, that is the civil engineering part, the transport of river sediments and pollution of air and water, design of piping system and fluid control system. These applications are in civil engineering department. And chemical engineering, design of chemical processing equipments, the turbo machines, the part of the mechanical, the turbo machines, pumps, turbine, fan and propeller etc. And aerodynamics, that is missiles, aircraft, ships, underwater vehicles. And biomedical systems, heart assist device, air artificial car heart and glucose monitor system. These are the applications of the area of the fluid mechanics. The number of fluid engineering applications is enormous, that is breathing, swimming, airplanes and wind mills, engines, blood flow, fans, turbines, and to name to a few. We think about that almost everything of the life is in everything in the field or nearer to fluid or move within the fluid or nearer to fluid. And these are the applications area of the fluid mechanics, that is missile aerodynamics, automobile aerodynamics, ship propeller and wind turbine. Okay.